fix that right there. All right. Good morning, guys. I'm not ready for this. I'm gotta make myself a cup of coffee, and all I had time for this morning was an instant of death wish. So give me a second to stir this up here, because this one is going to be another long one. Mostly because this is a topic that I don't want to cover again, but I also want to share with you guys what I learned. Before we get going, I think we've got the normal crew. We've got, let's see here, the normal TTP Southeaster. James, good morning and welcome. Enjoy Huntsville. I really wish I could have made it out, so have fun this time. There's going to be a good group there. Senor, I still can't pronounce your first name, but absolutely love it. He said, oh, thanks for the heads up on the FZM1 bags. Looking forward to your opinion on this topic. I use Olama air gap. Okay, yes, we are going to talk about that. And disclaimer out of the way, what I'm going to talk about today, I have absolutely zero background in this. More than anything, we're going to talk about AI. We're going to talk about local AI. We're going to talk about why I even spent my one day off yesterday looking at this and why I'm going to table it. But some interesting applications. And more than anything, even if you guys are not into AI or local AI or building knowledge bases, I want to share with you my process for tackling problems. I get the question from a lot of people of generically how to do a bunch of different things. And one thing I learned through the almost 45 years I've been on this planet is learning to learn. And I don't know what that was about, whether it's me having ADHD or, my parents, when they came here, dropping me off at a Montessori school at great expense, and then going to a Catholic school, first through eighth grade, getting kicked out of a Catholic high school, going into public, and then just kind of the unique set of things I did as an adult. So I want to share with you my process for learning and my approach. So the other thing we're going to talk about is something called an approach document. I spent 2 decades in the consulting space, and one thing that we built, regardless of what the vertical domain was, right? So whether we were going into the automotive industry, entertainment industry, biotech industry, we had ways of solving problems that were repeatable and reproducible, and that knowledge did not have to be recreated every time. So we spent a lot of time with our delivery services arms creating something called approach documents. So that's what to expect today. We've got Wyoming here, and welcome. And I love this avatar. This is from, I think it's Home Improvement. So if you grew up in the 80s and 90s, probably are a fan. So we got Boise representing. And let's see here. We got Ryan. Greetings. District 47. Good morning. Oh, Tango Oscar Mike. And then we also have Ryan Sheldon. Great topic. Local AI is a great resource for brainstorming. Yeah. So, okay, number one, I'm going to go on record saying I am very much anti-AI. I am 100% a proponent of keeping humans in the loop. And this is the main reason why I left my job 1 year ago in corporate America, was that they were trying to replace all of the knowledge workers with AI. And I did not want to be a part of it. Instead, I want to connect with you guys and focus on passions for radio. So I have dabbled with it very lightly in the past. I have never used things like Claude Code, for example, to generate code for me. So my view, if I were to use AI, and the way that I have used it in the past, is as a research tool for myself, where I keep myself inserted in the loop. And what I personally have found is that AI is very good at telling you or answering your questions in a way that sounds absolutely reasonable and correct. And my personal experience has been, in the areas that I am a deep knowledge expert or a domain expert, I find it to fail on a number of different areas. So that's why I've always been very leery of AI unless you actually know how to validate what you're seeing. All right, guys. So I don't have a moderator today, so you may have to just go crazy. I'll glance up occasionally. So let me give you a little bit of background. So I don't want to use a cloud-enabled AI service. mostly because from a few different angles. Number one, I don't mind paying for services I would use, but I don't want to promote and perpetuate the AI data center problem. Number two, I'm really getting more and more concerned about privacy these days, and I don't want to volunteer the questions that most people would normally ask Google and volunteer that to Anthropic or insert your preferred AI platform out there. So definitely want to make sure that if I use AI, it'll be something that I can run in my own systems. So my former boss, he called me last week and he just wanted to check in to say, "Hey, how are things are going? Do you want to come back to work for me?" I said, no, not at this point. I still want to do the YouTube thing and keep on doing what I'm doing." And he has been a huge adopter in AI. In fact, they're paying for the high tier plans, and him and his wife have done some incredible things with it. But he's also a very, very talented engineer. He was involved in the demo scene for the 6502 uh, processor at the early like Nintendo 8-bit generation. So it's funny. He's like, "Yeah, I don't need books to learn programming. I just read the data sheet of the microcontroller and I just write everything in assembly." So very deep knowledge, traditional engineer, but he's using it now, but he's using it from the perspective of a power user that knows what the right answer is, and he's using it as a tool. Second thing is he is uh, dual citizen. He lives in Switzerland, and that's where he was from. He's Swiss German, and he wants to build these systems, and he wants to use AI, but he's concerned. Same reason I'm concerned of building a business built on someone else's services, like all of the AI services. But more to the point, the Swiss are and the EU in large are traditionally more concerned with privacy than we are at the US at the legislation level. And while I don't agree, like I think the EU kind of screwed the pooch on the whole cookie nonsense. I think that is just a nag screen these days. It wasn't effective. His big concern is uh, if there are privacy concerns with AI, I want to see what I can do to run it locally. And just very casually, I think he manipulated me and he said, "So I'm curious if you're doing anything with it." I said, "No, not really." And he says, "Well, I'm kind of curious in local AI and what to buy." And I'm like, "What do you mean?" And he says, "Well, I'm looking at maybe an M4 Mac because it's got unified memory. And there's one that you can get that I believe has a 128 gigs of unified memory, which is good for machine learning." So we dropped the call. And again, Saturday was a work day for me. Sunday, I decided to wake up really early. I woke up at 2 a.m. and I was like, "Okay, what's the problem that I want to solve here?" And initially, the problem was, what do I buy for local AI? And that was the wrong problem to solve. Okay. Because if you do a search, for example, on YouTube, you'll see people that will start just comparing hardware. And that's kind of like saying, which radio do I buy? Which digital mode is right for me? Which radio service is right for me? And going straight to like a recommendation, right? So I took a step back, and for me, it wasn't so much which hardware should somebody get, it's what problem do you want to solve? And so I'm like, okay, so what problem do I want to solve? So I have always done all of my research as a traditional researcher. I go out and I establish what are all of these sources of truth and authoritative uh, sources out there. So, for example, when I was looking at NVIS communication, I didn't really go into the amateur radio space and I didn't go into Google. So, years ago, what I did was I did advanced Boolean searches using the advanced features at that time from Google. So I would say the authoritative places that I care about are going to be sourced from like a .mil site or a .gov site. And I restricted my scope of search not to the internet in whole or in mass, but to sites that are .mil or .gov. And then I limited it to white papers and first party research where you can have an abstract. And most people don't do this, but that's how I use it. And I went through and I read all of the literature from the US military over multiple decades. During that research, I found out who the authoritative experts were in that space. So, um, what I wanted to make sure is that if I was going to use I would most certainly go local. But to go local, the investment in hardware is extremely expensive. And I'm talking just to really kind of get started with a good model. My current research tells me the absolute minimum you need to be prepared to spend is just short of $5,000. And where the models are today for local use, probably closer to $10,000. Okay. And again, this is just with the day of research yesterday. So let's talk about how I solved this problem real quickly here. All right. Or not solved it, but I want to show you the approach. All right. We got a question here. I am familiar with Project Nomad, or I know of it, don't know anything about it. There are no plans to stick it into MCOM tools. In fact, what I'm going to talk about today in terms of local AI will never be something that should be a part of MCOM tools either. It's just a very heavy process and set of repositories. There is a place for tools like that, in my opinion, for your off-grid solution, for your off-grid network that you can connect to remotely from like a terminal on MCOM tools, but do not plan on running any of this thing here. All right. So let me be clear. My problem is I wanted to evaluate hardware before I evaluated hardware for local use. I wanted to make sure it solved a real world problem. And by real world problem, I wanted to make sure I could use it as a research tool for a specific domain. In my case, I wanted to start with something that I knew and actually could vet. So first thing I had to do was I needed to figure out what machine I could run this on. And I had an old Thelio System 76 from 2021. It's a very powerful machine, even to this day, but not powerful by AI standards. So let me just go ahead. So I pulled that out of a box I had. And the reason why I had that machine is because I was doing some video work for Adobe and editing. And my boss also wanted me at that time to test the NVIDIA RTX 2060, which has 6 gigs of VRAM or virtual memory. So it's pretty much been locked up and put away. So I took that out. So once I realized I had a system that had, and I'll read you the specs. So this one is it's overclocked at 4.9 gigahertz. It is an Intel Core i9 and with 20 cores at 3.7 gigahertz. So it's a beefy machine. It has 64 gigs of memory and it has a 1 terabyte Samsung 970 Evo Plus drive. Okay. And then I got that RTX card. So first thing I wanted to do was make sure I could install an operating system dedicated to this. I'm an Ubuntu user because I just like the simplicity. I'm using it for MCOM tools, but I wanted to make sure that I got the proper support for the drivers. So I opted for Ubuntu 2204, which is LTS, booted off my Ventoid drive, installed it. Everything worked minus the drivers for the graphics card. So step one was dedicating a machine that I had that I didn't have to spend money, and it was the most powerful machine that I happened to have in my fleet. So haven't spent any money because this is a proof of concept. And guys, this video is going to go on like this. Like I said, I'm trying to catch the comments here, but I just don't want to go down a rabbit hole and get distracted. So that's the architecture or the hardware that I'm working with. The next thing I had to figure out was how to load the NVIDIA drivers so that I could use the GPU for doing all of the AI processing. And it was actually pretty straightforward. I'm trying to see here what my actual physical notes are here. You can kind of see going through this here. But it turns out, and I did cheat and used AI for this. I did use a cloud AI for this. I installed the 595 driver using apt install NVIDIA-driver-595 and ran through a series of tests. So at this point, not terribly familiar with that process again. I asked this time the online AI, how do I verify that I have installed the driver correctly and everything is working? So the approach I'm sharing with you guys is what I like to call stepwise thinking or stepwise problem solving. So even if you're not into AI, I'd like to have these very small incremental steps. So best hardware I have available first, operating system that would probably suit me best next, install the driver, and then determine if that is configured correctly. So it looks like there was a tool called NVIDIA.SMI. Again, not an expert in the space, and it indicated that everything was configured properly. Now, for running a local large language model, the standard based on what my former boss told me was OLLAMA. And very simple, I installed OLLAMA, the current version right now. And OLLAMA essentially is kind of like a runtime platform for downloading models, running models, and checking into the state of running models. So very simple. It's command line oriented. In fact, I will go ahead and show you what that looks like. Oh God, we got like one person just taking over the chat here. All right, let's see. All right. Okay. Oh, and ultimately, we're going to get to a point at the end of this where I talk about how I build the knowledge bases and how I feed it documents like this. So we're going to get there at the end, but I'm kind of walking you through the entire process right now. Okay. So there is this utility you can install called OLLAMA. I am running, I think it's like what version am I running? 0.32.9. Okay. And OLLAMA has the ability to download one or more large language models and also run them. So I'm going to run OLLAMA, and I'm going to show you and list the models that I have, minus the ones that I have kind of made my own. So I'm going to eliminate any model that is called concise. And this is just my nomenclature. And let me go ahead and make this a little bit larger so you guys can fully see this a lot better on tiny screens. Okay. So if you guys are not familiar with AI, and I'm going to give you the super, like my style of explanation for it. All a machine learning or all a large language model is, it's a way of predicting the next word or token that comes next. So as a really simple example, in fact, I'm going to do a giveaway. You're going to have to send me an email, but I'm not too happy with the way these Heltec version 4s came out. The back of my custom case has a little bit of flex. I've got 100 of these, and I don't feel comfortable selling them until that's resolved. But I'll give one away today. You do need to bring your own board, your own IPEX to SMA connector, and your board and antenna, but I'll give away a case. So here's the example. And the first person to complete the token will win it. Let's say that this is what I'm saying. It was really hot today. I went for a run and I am sweating. And now it's time for me to take a fill in the blank, right? The first person to get it will get it. So based on all of that context of everything that came before, me being hot, me going out for a run, me being done, now it's time for me to take a insert the blank, and Mr. Senior, you win. So that is really at the most simplistic level what token generation means. It's the ability to predict with a certain level of confidence the next token or word. So yeah, it was indeed shower. Senior, if you can send me an email to info@thetechprepper.com, I'll go ahead and package one of these up for you. I've got them in orange, brown, OD green, black, and brown. Let me know which color you want. So when we're talking about large language models, that's all we're talking about here. And each model has different characteristics here. And let me go even bigger since it looks like we got a little bit more room here. Okay. Oops. Okay. So you can see here, I've got a model called Gemma 3, and it has this thing after the colon called 27B for billion. Okay, and that means that's the number of parameters and weights that model has. In general, the larger the number of the weights in the billions, the more capable the model is supposed to be, and the more scaled up your hardware has to be in terms of the graphics processing, virtual memory, and all of that stuff. So you can see for Gemma 3, for example, the size on disk is 17 gigabytes. That is massive. And kind of the rule of thumb is you want to make sure, and this is what I established just in the one day that I looked at this yesterday, because this is not my area. The rule that I came up for myself and actually wrote it down was that I'm using roughly 80% of the total virtual memory that I have on my graphics card. So 80% of 6 gigs, uh, which clearly doesn't fit here, should be the max size of the model. Again, people can get pedantic, but again, I'm a simple guy. I like simple explanations. That's just my rule of thumb. So technically, this model won't work here. It's not what I started with, but I'll tell you why it's listed here. The models I did start with were the Llama models. So Llama 3.2, which only has 3 billion parameters, you'll notice that that one is about 2 gigabytes. So that more than fits into the virtual memory, right? But as we'll see, there'll be a performance cost of doing this in terms, or not performance cost. The performance will be fast in terms of spitting out tokens and how quickly you get to an answer, but the answer is going to be wrong. And I don't. What drives me crazy about a couple of the YouTube videos I saw is that their only metric was looking at token speed. And my personal advice is I don't care how quickly you can give me a wrong answer. I'd rather have. I used to work with a scientist when I was building genomic search engines, 15 years ago, and you would ask her seemingly a simple question, and she would look at you and occasionally blink, and then you would get ready to move on to something else because 5, 10, 15 seconds had passed, and then she would give you an answer. And it was always 100% accurate, and she really wanted the time to think about it and give you the right answer. Um, so that's my goal here, is to get the right answer. So I tried a few of the other models, for example, Llama 3.2, 1 billion. The one that tends to be the sweet spot for me based on my hardware, even though it's also wrong and doesn't meet my needs, was Llama 3.1 with 8 billion parameters. You can see it's 4.9 gigs, and it was able to pretty much run entirely on the graphics processor, which again is 5 years old and really not well suited for this. So then I tried a few other ones here, and you can see, for example, Quinn 2.5 coder. This one is a model that's geared towards coding, not towards building general purpose models. The models that I actually like the best and have had the best experience with have been, for me, the GPT modules, like GPT like 5.2 or 6 or whatever the heck their current one is. But you'll notice here, like GPT 120 billion, 65 gigs. I mean, I'm not even close. For me to even build the system to run this on the GPU, I would need to spend about $5,000 minimum. Okay, so every model has different areas in which it excels at. So for these purposes, we'll say coding versus maybe like domain knowledge, and there's a trade-off to each. But again, my purpose is I want to have a right answer. So the process that I went through for all of this, and I can show you some of the original work I did here. And I've got something I could probably publish too on my NomadNet page. So the original test that I went just to kind of learn, what was it here? Custom model. Okay. All right. So this is kind of the first way that I looked at the world. I wasn't sure which model would work the best. I started with, some of the easier models. So the first thing I needed to do was download a model, right? And the way you do that is with Ollama, pull, and then you specify your model and it'll download it. So it's now stored on your system. And again, the list that I have here is this list. So for example, I already have it, but let's say that I want to download a model to experiment with. In fact, the first one I experimented with was, I think it was the 1 billion, right? And we can, we'll even, I wasn't planning on doing this. So we're going to do Olama. We'll do pull and I'm connected, guys, to the System 76. This is not running locally. Olama pool. So you can see I already have it there. And then to run it, all we have to do is do Olama. Does it run? I've been using wrapper scripts the whole time because I can't. Yes. So we're going to do Olama run. And then I'm going to go ahead and paste that model. Okay. So, I need to learn how to spell here or get some glasses. Okay. So now what it's doing, it's loading into memory a model called Llama 3.2 with 1 billion parameters. And I can ask it a question. And the other thing we can do is we can also check to see, for example, how the CPU is doing. We can also check to see whether this model fits entirely into. So Olama PS for process will show you. And you can see here, this is a good metric. 100% of this will fit in my GPU, which means it's going to be very, very fast. It's going to be wrong, but it will be fast at telling me the wrong thing. Okay. So guys, like I said, I'm not an expert at all. I have exactly one day in about 16 to 17 hours of total local AI experience. I'm just sharing that with you. My goal is not to tell people what to do. My goal is to kind of walk people through how I like to solve problems and what I've learned, because ultimately when I have time, I want to build a domain specific local AI model specifically for solving off-grid verticals, whether it's medicine, whether it is construction of cabins, for example, water purification. So I'm just walking you through what I learned from the ground up. So I really can't answer too many questions here. Seems like everybody here has way more knowledge than I do, but I just want to share the process. So suffice to say, with this small model and my very modest hardware from 5 years, using the Olama PS command, I can see here that it is 100% running in the GPU. So it's scaled. Okay. So there's a question here. So this is, but why AI? You know, the way AI works is by creating weights between data points. Then RNG is what is statistically likely to resemble training. For my needs is that my background for the last 20 years has been building enterprise search engines. I have built some very large websites on the internet in entertainment, in biotechnology, automotive space. So I was always ingesting large quantities of data sources from within these organizations and doing very sophisticated entity extraction, document enrichment, transformation, linking documents together, so that when you come to a site, you see kind of everything you need. So for me, I know where the sources of truth are. I want to confine the sources of truth. I don't necessarily want to read which I have, a 375 paper on VOACAP, Voice of America Capture Analysis Program. So I want to use me knowing the answer of what I'm expecting to build an AI model that I can run locally to build my own personal off-grid knowledge bases and potentially offer those through radio services as an interface. So that's why I always do my own research. I don't need AI to do my research, but this was just an experimentation to see if I could. Okay, so let's go back over here. And I have a question file that I should have in here. So for each test, I created a script called run dash number one, question one. And for example, this was one of the first questions that I knew the answer to, and I was just kind of curious to see how every single AI model will work. Okay. So we've got Olama 3.21 billion, which is a crap model, but it fits. We're going to paste this here. And you see how quickly it's spitting out tokens, right? So each one of those words is a token. It was fast. And let's go ahead here and see what it gave me. All right. So it says when it comes to daytime high frequency HF broadcasting. Well, I guess I didn't tell that was an amateur radio operator. Broadcasting in Arizona, you'll want to focus on a specific frequency range and mode to ensure reliable coverage. Here's a recommendation. There's also one problem with this. I don't like how it's giving me this data. I'm going to show you the second thing I did. So it says frequency 7 megahertz or 30 megahertz is good starting point for daytime HF broadcasting in Arizona. I don't like that it's using the word broadcasting. Should be transmitting for the amateurs. This frequency range covers the majority of the state's terrain. So I'm expecting with this question, this is kind of like a test question I want to use. I'm expecting a very different or a very specific answer. And I want it to arrive at the fact that it needs to use NVIS as the propagation technique, near vertical incident skywave. So it's going into a bunch of different stuff here. I think 30 megahertz is the wrong one for statewide coverage. Right now for antennas, it's talking about a Yagi, which is probably good for short range communication. It's talking about a dipole antenna. And it's giving me a lot of interesting stuff, but I think it's mostly not the answer I wanted or expected. So very, it doesn't work for what I'm trying to do. Okay. So I did have a follow-up question to kind of help it along. And here's the follow-up question. Again, these are the test questions that regardless of the model, I know the answer for both, and I want to assess the model of whether it's worth my time. All right. So we're going to go ahead now and give it a follow-up question. And my question is, what propagation mechanism are you relying on for reliable HF communication at distances roughly? So I'm trying to help it between 50 and 500 kilometers. So in a lot of cases, that should rule out the higher frequencies and should rule out this idea of a directional antenna like a Yagi. And in a lot of cases, they will also suggest things like 20 meters. I've seen this with some of the models where 20 meters won't work because there is some ground wave propagation, but usually I want to say up to maybe 20 miles. I haven't looked at the graph in a while, but certainly not for me to get to northern or southern Arizona. Be preferable. So let's go ahead and ask it again. Performs very well. So if you look at online metrics about just tokens alone, you're going to run into an issue here. So let's see what it says here. And it's giving us all of its thinking. Okay, here we go. All right, guys, if you're joining late, like I said, this is me sharing, not being an AI expert. If you want to watch the beginning, I hope you guys start at some point and catch the beginning for the context. So when it comes to reliable HF or high frequency communication over long distances, the propagation mechanism plays a crucial role. I'm relying on a combination of factors to determine my preferred HF mode. All right, so then it's got like a section here called propagation mechanism. For long distance HF communication, I rely on ionospheric refraction, which is true, and the, I can't pronounce that, diffraction effects. Those mechanisms allow for radio waves to bend around the Earth's curvature, enabling blah, blah, blah. So it's giving us a bunch of just basic HF theory, which I don't want in my response, and I'll show you how I'm fixing that. Okay, so here it says why 20 meters is preferable to 40. So it has already lost the context that I'm asking about coverage in the state of Arizona. 20 meters outside of it is a bad band because it has skip. Those low takeoff angles will shoot outside of the state. So this model is already not worth my time. So I just wanted to call that out. So anyways, it goes on like this. So my next big issue with something like this, we're going to go ahead and put /by and leave, is that it also gives me too much information. And I call this the pedantic PhDs that I have worked with. Way too much is going on here. So the next thing that I wanted to do was create this guy. So I created something called a model file. And we'll go ahead and open up the first model file. This is using a different model. You can see here it's using chat or GPT OSS 20 billion. But the most important thing is this prompt here with the system and the three uh, quotes here. So number one, and this is just my style of how I want to get a response back from my local AI. Number one, be concise. Number two, always start with a bluff. Big thanks to S2 Underground. Smash that thumbs up button if you guys like S2 Underground and my stuff. Really can appreciate you. But if you've seen his stuff, he starts every video with a bluff. The bottom line up front, it's typically 1 to 2 sentence summary. So if you don't have time to either read the full report or watch the 5, 10, 20, 30-minute video, you can usually walk away in about 10 seconds with that 2-second read. So I like bluffs. I like short paragraphs and bullet points. I don't want all of that background information. I don't need it to give me a dissertation on HF diffraction. Do not repeat the question. Don't use excessive markdown. And I want to also make sure I cap it. So even though that model kind of sucks, we're going to go ahead now and give it this prompt here. So what I want to do is we're going to create something called concise. So I'm going to make a copy of this model file 1, and I'll just call it, I don't want to get confused with what I'm working on. I'll call it 0 because technically this came before the test you're seeing. I'm going to call it model file 0. I'm going to list my Ollama models. I'm going to grab that real tiny model we were just working with here, which was it 3.1, guys? Yeah, we're going to grab this model, 3.1. I can't remember what we were using. Let me see what we were using real quick. History, Ollama. Oh, sorry, grep, Ollama. Okay, yeah, we're using 3.21 billion. I want to use the same one here so we can kind of see how that changed. And that's the important for each of these tests here. So we'll open up that, that file 0. I'll go ahead and switch which model here at the top. And we'll go ahead and paste that. And now what we can do is we can create, based on another model, one that has that one. So we're going to type in Ollama, create, and we're going to use that Ollama concise. And we're also, or we're going to call it, Ollama 32-1 billion. And I call it concise because I can create different model files to do different things for me. So it's going to have to recognize all that. And then I want to feed it that file that we just created. So right now what it has done is it has created a new model called Llama 3.2-1 billion. So I'm intentionally encoding the model here. Concise is my nomenclature for saying I want bluffs, I want bullet points, and don't give me stuff over 200 words. And I feed that in. So now the cool thing is for me to run this model with my kind of pre-seeded constraints, think of this as the constraints. We're going to do Ollama run, and we're going to run our, well, I wanted the concise version. Sorry, guys, I'm on a virtual session here, so I can't use my normal copy and paste hotkeys. Oh, come on. You're not going to let me paste? There we go. Okay. So now it's starting up again. We've got our prompts. Let's go back and let's grab. Again, we want to always use, in my opinion, as someone who is brand new to AI and local AI, so I might be wrong, my approach. We're going to go ahead and ask it the same question we did. And what we should see is now something that uses a bluff, something that uses bullet points, and something that is 200. Okay, so you can see still relatively fast, and you'll notice a difference here. So first, it starts out with a bluff, and it says, "Oh, this is good. This is good. Daytime HF, very low frequency coverage for Arizona." That is correct. I was looking for NVIS in particular, and something that refers to between 2 and 10 megahertz. For recommended band and antenna, this is wrong. So this is 100% wrong. So it's saying the band is W7KOK. I have no idea what that is. And this frequency range, 30 kilohertz. Yeah, that's just wrong. I was expecting something between the 80-meter band and at the top end, 40 meters, but sometimes 30 meters. And then specifically, I'm looking for a wire antenna that is deployed at 1/10 of a wavelength. So while this all sounds good, it's all spelled correctly. Not a big fan here. So what I did then at this point is I went through, got a lot of notes here. I don't know if you guys can see. I'm a notebook guy. So I started with all of the different models and I started to score the responses, right? In terms of, was it accurate? Was it just wrong? Did it hallucinate? All of these things. So it's a very progressive build. Again, my goal right now is I know what the answer is going to be, and I don't want to make the investment in $5,000 or $10,000 of hardware, which I don't have, until I realize that this stuff works. So the next the next thing was to figure out larger models. So let's go ahead and, as I showed you guys, we're going to go ahead and go buy here. And we're going to do another Olama list here. So I went through, and let me also filter out the my versions, which were the concise. So I'm using grep here to filter out the lines that were mine. So let's take a look at, people said, you know what, this one should be a lot better. The Quinn 3, 8 billion parameters. So it's quite a bit larger than mine. It's 5.2 gigs, and it also can fit within my graphics card and my GPU. And again, guys, if you join late, my goal is not to tell you what to do, just show you what I have done, because this is something I don't have the bandwidth to do. But this is how I approach problems, if it means anything to anybody there or here. Thank you. Let me take a sip of coffee. Someone says something about something being interesting. It's from Sign No Mine 3080. Interesting. I've been so secluded working on my own mashup model that I was not aware of this. Very cool. The same person is asking, what budget are you working with? I'm not working with any budget right now. This is the whole point. And this is what my boss told me, or former boss. He said, I want you to find hardware that would be good for local AI. And most people will go straight into, what token count do I need? And going into the valuation, where I want to prove in the real world a problem that I personally need done. And we will get there at some point. So once I figure out which model and which AI offline techniques work, then I can figure out what size I need. I could figure out whether, does that make sense for my budget versus the value. It feels like right now, if I'm able to get this to work, the lowest I can get into this is $5,000, but then I'm kind of starting at I'm already maxed out. It almost feels like the budget needs to be $10,000 for either GPUs or unified memory that gets me to 128 gigs or 196 gigs of available in the GPU world, VRAM. In the kind of like the Mac world, the unified memory would probably be there. Okay. So Tim Harper, thank you. W5TAH, another ham, 73s. Listening and learning. Thank you, buddy. Yeah, this is all about learning, guys. I am not an expert, so please, please, please. I shouldn't even be talking about this, but I wanted to share what I learned. Okay. So next step here was to evaluate, again, so through the same process. So what you'll see here is if I do a listing here, you'll notice I have a bunch of these different model file 1 or 0, 1, 2, 3, 4, 5, 6. And the process was, okay, what's the next biggest model? And let's go ahead and re-benchmark it. So let's take a look at what model file, let's look at 2. I forgot how far we went. Let me see which one was good. Okay, everybody had good things to say about Quinn 3.5, 27 billion, which does not fit. Let's go ahead and take a look at that one. I forgot Quinn. I forgot which model file that was in. Give me a second. Okay, so that was model 3. So we open up model file 3. You'll notice here that we're giving it the Quinn 3 model, and we're giving it the exact same, to be fair, the way we want to constrain what the AI is going to give us. Oh, that was a good comment here. Looks like we've got a, I love it. Firearms guy on the channel. Cheers to you, buddy. All right. So we're going to use this model file 3. So I did create a concise one. So again, you see that I've got model file 3 here. I also created a wrapper just to run it called run 3. And you'll notice here that it's just going to run the concise. So I want to also have the ability to go back and revisit everything. I don't want to have to remember it. So that's the other part of my process. I know there's tools to do this, but again, people hate when I say this, but I am really not that bright. And I have no short-term working memory. It's really terrible. And I need to have all of these aids here. So for me, I can have test 1 is called 1. The script to run it has a 1. The script that has the question has a 1. And the way to run it has a run. So very, very straightforward. So we're going to go ahead and run 3. So it's going to start Olama. Olama is going to load that model. And what we're going to see here is that this model should not fit in my graphics GPU virtual memory. So a couple things to observe here. You could see that this model has more parameters. I think it was 27 billion, took a little bit larger to start. And now if we go ahead and do let me copy our question. And then we're going to go ahead and let me make that bigger for you guys to see it. Oh, you're not seeing. Guys, you got to help me out here. We're missing stuff. There you go. Really, nobody wanted to help out there. Okay, so shoot. Okay, so long story short here, this is what I was saying. Model file 3. The only difference was that it was referencing Quinn 3.5, 27 billion. And then, like I said, I wrote a little wrapper script called run 3-sh, and it just allows me very quickly to see, okay, here, model 1 is associated to run 1. Same thing with all of the output tests that have all of my notes on how well that performed. This is great. This is from Colin, MCC207, another unscheduled live stream. Yeah, I went down a rabbit hole yesterday. I don't have time to continue to explore it. Wanted to share it. Didn't have time or don't have time to do a video. In fact, I'm not the guy to talk about AI, but I did want to, even for my reference, I want to come back to this radio for me 6 months from now when I revisit this topic. So thanks for joining. Okay, so we've got run3.sh running Quinn 3.5, 27 billion. First thing we want to see is if we do Olama process listing, what we're going to see that is different from the other, the first one, we're using one of the smaller llamas. You can see here that the size of this model now is 17 gigs. My graphics card only has 6 gigs of virtual memory. And you can see under processor, it no longer shows it all running in the GPU. So if this model works and meets my needs, I know that I need to scale up the hardware. I will tell you right now, this model doesn't work for me. So I'm not going to scale up. But you can see here, it says 79% is running on the CPU and only 20% is running on the graphics processor. Now I do have, like I said, 20 cores here. I know that's tiny. When we run this, you're going to see all 20 CPU cores at the 3.7 gigahertz essentially maxed out or close to it, and the load on the system is going to be like at 10. So we're going to have a pretty high load here. All right, so we're going to go ask it the same question as before, our baseline. So for daytime HF to cover the state of Arizona, which band and antenna do you recommend? So you can see how boring this was. I spent 16 or 18 hours yesterday going through this just to really knock it out. So you can see right now it's doing its thinking. And this is kind of cool. It's actually showing us in real time its process for evaluation. And it's kind of cool to see what's going on. So you can see here, it's analyzing the request. It has identified that the topic is HF radio communication during daytime coverage in Arizona. And this is where the token count comes into account. You can see it's probably doing about 1.5 tokens per second. So if this model performed on my hardware, that is probably unacceptable for real use here. And you can see it's going through and looking at the constraints of that we put in that model file of be concise, start with a bluff, a bottom line up front, and it's going through all of this right now. I'll tell you the model that had the most promise, just to put the cart in front of the horse, was DeepSeek -R1 70 billion. When I ask it this question, it takes over 20 minutes to run, and it is incorrect. You can see now that our CPU right now, they're all either pegged at 50 or 75%, and it's because it doesn't have enough room to do the inference on the GPU, on the graphics processor, because I only have 6 gigs, and it's offloading it. So that's why it's so slow. So again, if the model worked and was accurate and precise, and I could have confidence in it, I would scale up accordingly. Again, we're not there yet. So I just wanted to show you this one here. I don't know if I want to have you guys wait, but we're going to wait because I do want to see what this spits out. And then I want to show you how I'm actually going to solve this problem. And it has to do, spoiler alert, with something called RAG. And it is retrieval augmentation generation. And the way that RAG works is you can give it a set of content, like a knowledge base that it can refer to. So if you've ever seen, if you use AI, where it says sources, that's where RAG comes in. So it takes the general model and it does lookups to sources you provide. So if you guys had looked at the thumbnail, for example, while this is generating. Oh, and remind me to show you the approach document, because I wrote all of this thing up this morning and now I got to move on to other things. This is not my focus, not where you guys are going to see another video. For example, let's take a look at, this was in the thumbnail. I absolutely love the work that Fiedler has done on using NVIS for radio communication. So this is one of the things, one of the articles from the Communicator journal that I identified as someone who knows where the authoritative sources of truth are. And my approach, if I were to continue to do this, is to use the retrieval. So we retrieve this information, we augment it with the model, and then we generate the response. So on my workstation, for example, I have thousands of PDFs, Excel spreadsheets, markdown notes that I have either created myself, pulled down from the internet as web pages. And if I were to take this project on, I would put all of that into what we're going to see next, something called Open Web UI. And you can now start to build something that gets us closer to our what I call domain specific knowledge bases and knowledge stores. Okay, let's see here. I want to see if it's finished yet. Yeah, it's still going. Oh, this is a good sign. I like this, what I'm seeing already on this one here. So this, again, this is with DeepSeek R1, was it, how many billion? 70 billion. It says, and it's still thinking. It hasn't given us an answer yet. It says best bands, 40 meters is off. Oh, that's wrong. This is 100% wrong already. So it says best bands 40 meters is often too quiet during peak daytime for long hops within the state. I could not disagree with you more. In the real world, I use 40 meters pretty much 3 to 4 times a week, have been doing it for 5 years on 5 watts, almost no power. And I have regional comms with guys that are 10 miles away from me, 20, 40, 100, 200, and just above 300. So again, you can see here where if your first inclination or reaction was to go out and buy hardware, you would be woefully disappointed because on its own, just the model by itself, DeepSeek R1, while it does a lot of good things, like if you were to ask it to like generate a story for you or do spell checking for you or give an answer to something that is very well known in the public domain, it's going to do probably a very good job. But for stuff that I want to do for deep research and stuff that we in the off-grid community want to do where we may not be experts, we really, in my opinion, I'm not an expert, we need to move to domain specific local AI if that is a thing, or don't do that and do what I do. And I'll even show you. Let me go ahead and let me open it up top first real quick. So someone asked me why AI. I am a free thinker, always have been. Don't have a problem reading 400-page white papers. That's just kind of my thing. Resources. Okay, here's a good example. While this thing is still going here. So over the last 6 years, I have an offline repository that I have built for myself. I don't like looking stuff up online, especially with the way how toxic and how hard it is to use search engines today and how wrong even cloud hosted AI models can be. So for the last 6 years, or actually more like since 2017, it's been almost 9 years, I'm collecting topics on my local communications group, ANMAR. I have frequencies, I have SOPs, I have radio net procedures. A big fan of Amron and the work that JJS are doing over there. Hit the thumbs up, guys, button if you guys join late and you like Amron, you like what I'm doing. Antennas. I've got just about every antenna I've ever come across, whether it is manuals, you name it, APRS, bandwidth, bulletin board systems, comms plans, the software-based TNC called Direwolf, DMR, EMPs as they relate to radio, EasyNIC, which is antenna modeling, field cards that I have written, field manuals, which I have written, FLDigi, great mode, formulas, frequencies, FAQ, FT8, Maidenhead grid stuff, HF communication, JSA call, manuals, Mars, Maricopa County Emergency and Communication Group, which I am a part of occasionally, Moto Turbo on the Motorola stuff. So this is the personal list of my knowledge base. And while I have a background in library sciences and enterprise search and know how to build ontologies and taxonomies, and have structured this, I don't want to go back. There are hundreds of thousands of pages here. So back to the gentleman who said, why AI? It's like, if I can build a local AI that never goes out to the internet ever, I can have that model stored locally. I can train it with my constraints, and I can build a knowledge base that I feed it with all of this and do the tweaks. This would be a force multiplier, because I got to tell you, I have a hard time today with people watching my 10-minute videos, let alone my 2-hour streams. The TikTok generation who's only capable of processing 30 seconds, I feel sorry for that generation. And there's a reason why, even with this amount of data on its own, is not effective for a lot of people, because there's a lot of browsing and hunting. So my goal, if I ever have the opportunity, because I don't, I've got MCOM tools R7, I've got videos I got to do, I've got shortwave that I'm doing research for SIGINT. I don't have time for this, but I just want to be very transparent on where I'm coming with, on how, if I were to do this, how I would solve building an offline only, off-grid, domain specific prepper knowledge base that has the right answer all the time. Okay, so let's see. Let's go back here. Let me answer a quick question. Let's see here. Some Amron stuff. Okay, cool. So you can see here it's still going. It's really wrong. It's going to sit here probably for about 20 minutes. Okay, so I'm going to just hit Control C here. We're going to kill that with buy. Okay. So I started to write this thing called, so I pivoted away from this and realized that I had to go to I don't want to get the acronym wrong, of RAG. I think it's retrieval, augmentation, and generation. Yes. Yes. Okay, we're good. So I quickly abandoned this process of well, I didn't abandon. I decided that I was not going to use Olama directly and the models directly, even with the constraints I put on the model files here. But this is the same systematic approach we're going to be using. Excuse me. Okay. So what I pivoted to, and I did have to do a little bit of research here because, again, I'm a search engineer. The way that I would solve this problem is asking another authority of, hey, I'm a search engineer. I know where all of the data sources of truth are. I know that I want to use local AI. And I know as a search engineer, there is the aspect of finding that data source, whether they're online sites, PDF files, markdown files, whatever the case is, and then being able to ingest that. But ingestion alone isn't enough. In the search world, we did something called document enrichment or document processing. And usually you would have to support a bunch of different ways of dealing with different media types. So how do you process a PDF versus an image versus an Excel file versus a Word doc versus a website, right? So there's that bit, right, that would need to be built. I know how to build this stuff all day long. Built a cannabis search engine doing that. That went out of business, because of COVID. But long story short, I knew that there was a way. I know how to do document processing where you clean up that data, enrich it, you extract things like named entities, like proper nouns, things like that. You do a bunch of like tokenization, you do stemming, you do a bunch of like linguistics processing on all that stuff, and you would stick that into a search engine. So I figured that had to exist. And where it led me to was something called Open Web UI. And we're going to take a look at that next. But I do want to address Colin here. So Colin says, thanks for the great session. I use AI in my work a lot and have been looking into local LLMs for MCOM work. Makes sense. We leverage it to search all the local data we have. Yeah, thank you, Colin. Appreciate the 2070 there. What's the significance of 2070? Is that, I'm not sure what that is, but do appreciate it. And like I said, this is just one guy's opinion on the YouTube machine here, not the expert for sure. Okay. So in my notes here, and again, I like paper notes. They make things a whole lot easier. I realized that I didn't want to go down the route of building my own document processing pipeline that dealt with retrieval, extraction, enrichment, and then put it into a data source that I'd have to set up. Oh, okay. So Colin says 207 is the main area code. I love it. Okay. You kind of doxed yourself a little bit, but no worries. Maine's a big state. Okay. So I found this thing called Open Web UI, which I downloaded online and installed. Okay. And Open Web UI is the thing that lets us run the same models, even the ones that we create and feed it a model file so that we can constrain it, but we could also do knowledge bases. This is where it gets really cool. Oh, what's going on? Screw that up. All right. Wrong window. So I started a new folder I called rag-kb. And that's for the retrieval, augmentation, and generation for KBs, for knowledge bases. Okay. All right. And then I wasn't sure where I wanted to go with this. So I wanted to make sure I didn't try to solve all of amateur radio. So that's the other big mistake I've seen in my career over and over. When people want to do these, what I call fast fail proofs of concepts, right? How do you quickly get to a point where you have an answer to take you to the next level, to realize if it's even worth it, right? If the thing fails, there's no reason to keep putting effort, but you also don't want to learn everything and spend 3 months learning it only to find out it fails. So my choice here was to create a folder called NVIS. This is an area I'm very familiar with in the amateur radio space, and I know where the sources of truth are. So I wanted to start small and start from there. So the first thing I did, and this isn't a complete source, I created a file called resources.md. MD is a markdown file format. And what I did was, I told you guys, when I was initially searching or researching NVIS for regional communication 6 years ago, I don't care what the general internet has to say about it. I do care what the government has to say about it, specifically the military. And I do have that collection of documents in my offline repository. So I know that the Marines has a radio operator handbook, so we can open that. This one is another one. I forget what it's another one from the Marines. Then we got the tactical employment considerations of HF radio in cavalry squadron. And then we have the one from Colonel, I think it's Colonel Fiedler, retired, the Army Communicator, which is a publication that talks a lot about radio. Unbelievable resource, right? So I didn't go crazy, right? I didn't spend an entire afternoon. I said, okay, these are the 4 that I have read. And I'll show you what that one looks like. So I created a little folder here called PDFs. I downloaded all of them. And again, I like to have traceability of where I got this stuff. That's why that resources file exists. And we're going to go ahead and we'll open that PDF real quick. So guys, is this helpful? Not so much, I guess, the local AI on its own for a potential need for off-grid communication, but also kind of just the stepwise baby step process that I'm going through, because that's really what I want you guys to walk away from, because you could apply what sounds like an intimidating problem to solve, and you can really break it up into a smaller one. And if you use these techniques of kind of quickly getting to the next step and proving a concept before you moving on to the next, you could save yourself a lot of money. Because I'll tell you, if I was still had my day job from last year, I probably would have pulled out my credit card and probably would have bought a $5,000 local AI machine on impulse. But I can't do that anymore. So it's good to kind of see, let's prove the technology before figuring out how to make an investment like that. Okay. So again, this was one of my favorite reads. It came from a mill site. It's from Lieutenant Colonel David M. Fiedler, who's retired. And he talks a lot about using NVIS communication in urban environments for combat, where you have a lot of like infrastructure in the way, like buildings and stuff. That certainly causes a problem for higher frequency stuff like VHF communication. UHF works a little bit better, but you ultimately have a constraint. And he talks about, you can see here, we've got this guy over here with the Manpack radio, and he's got a whip antenna bent over. And this is what allows those signals RF signals to radiate up and straight back down. So my goal was to help the model using retrieval, augmentation, and generation RAG to go through this. And this is 100% a paper that I have read, I'm familiar with. You can see here, we've got a dipole diagram over here. We've got radiation patterns. He talks about frequencies. Let's see here. There should be one here that also shows. There was a classic one that showed the Humvee. But anyways, you get the point. The goal for me was to identify good sources of truth. Let's go ahead and open up the radio operators ones. We're going to open up the MC, and we'll do a search there, MC. And we'll go full screen, and we're going to search for the word NVIS, right? And we can see here that this document refers to it. Okay, so this is a valuable piece of information. right? And this is what we want our model to learn. It says the use of near vertical transmission paths. So near, what we mean by near vertical is that the radio waves should take off at nearly vertical, like straight up, so they come back down. On some frequencies, when you shoot signals straight up, they just shoot straight through the ionosphere and go off into space. They do us no good, right? So 20 meters would absolutely probably do that. 40 meters, or that frequency range from 2 megahertz to roughly 8 to 10 megahertz, put us in the 80 meter to 40 meter band. During the day on 40 meters, we'll shoot up at those near, let me see here. What do you call it? So near vertical, up and back down. And they shower the whole region. And the example I like to share with people is you could take like a water hose. And I did this in a video years ago. And I drew a little box around myself to represent the state of Arizona and shot it straight up. And you could see how that water comes up and showers a whole area. So that is the question, or the answer to the question I wanted, with that very simple prompt, that these giant models that have spent billions of dollars in R&D and infrastructure are getting wrong. Current edge, cutting edge models running locally, that DeepSeek R1 can't figure it out. So we need to help it a bit. Okay. So you can see here, lowering the antenna will increase the angle of transmission and provide broad and even signal patterns in a large area. The use of near vertical transmission paths is known as near vertical incidence skywave. And it says raising the antenna will lower the angle of incidence. So rather than having short takeoff angles, which are good, like if I wanted to get into New York or the Southeast, I would use a different technique, right? So by lowering the antenna, we actually raise that angle of incidence so that we can cover a regional area. So anyways, it goes on like this. So the point is, I'm not going to call myself an expert, but as someone who trusts the research that the military has done, because this is in fact a technique that they use. This is the technique that NGOs, that everybody uses. Like when stuff goes sideways and nothing else works, if your goal is regional communication, get yourself on the 80 through 40 meter band, sometimes 30, drop that thing at 1/10 of a wavelength, and you're going to be able to cover your area. So we're going to help the AI model learn about that. I'm going to read a couple of these real quick. So it says, this is from NVBL42. I wonder if you're a Jackie Robinson fan or if you're a Hitchhiker's Guide to the Galaxy fan. What's the 42? Or you were born in 1942. If that's the case, you're a year younger than my father. Okay, I've been watching a lot of AI LLMs and how to integrate them in home business operations. Having a model for MCOM is a great idea. Okay, yeah. This one says, I work in a very remote area, so out of necessity, I had to invest in a way of communicating and being informed in the setting. Hell, I'm using Starlink right now while in the mountains talking to y'all. Yep, I'm on Starlink as well. We only get, we're on a well. We only get electricity, and it's better now, but it was unstable for years. The ladies' man says, sounds like a Hustler resonator plus whip. Yeah, and in fact, the Hustler resonator works really great. I've seen this behavior. Okay, so that's the context. So, all right. So you know what? KN9DEM, please send me an email to info@thetechprepper.com. I want to send you another one of my Heltec V4 cases, just because it's always great when you run into a like-minded person. So 42 is the it's the answer to life and everything. If you guys are Hitchhikers of the Galaxy fans, or Hitchhikers, The Hitchhiker's Guide to the Galaxy by Douglas Adams. So I'll be sending away 2 of those. All right, so let's get back to this. So I want to share with you first my approach document. I am going to share the approach document with the members. If you guys are Buy Me a Coffee members, or do you guys want me to clean this up and send it to you in the newsletter? Let me show you what I put together. So I called it approach.markdown. because there's a lot of information here that I've already covered, and this is I will certainly forget it. So I spent some time cleaning it up. So the approach document talks about uh, what the purpose of the document was, and specifically which hardware I'm currently using, so that people will understand where I'm coming from. We talked about the beginning. Talk a little bit about the operating system and the software that we're using. I also talk about the models that I just happen to experiment with. Again, I'm not an expert here. I don't know what's out there, but what I did try to do is take a look at the different AI families. So, for example, we can look at DeepSeek as being a different class of AI model than the Llama models, and as probably a different one from GPT or Gemma, and certainly Quinn Coder, for example. So I did experiment with all of these, and like I said, I went through the cycle I showed you guys of um, create the script to or download the model, which took a lot of time on Starlink. Load the model, ask the question, evaluate it, and I went through each one of these models kind of over the course of several hours. Um, I use 42 as a seed hour. Senor, thank you so much for being interested in this approach document. Again, it's just one guy's take that has no business sharing it. Rick says, I'll take the cleaned up version to study. Cool. Again, don't use it as gospel or Bible, just more of the approach. So then I talk a little bit about test execution, and really quite simple. I showed you guys, we download the model to test. I give you the command or for myself to look at. Um, then I talk a little bit about why I create the model file, how I named it, and why I want to have those constraints. And again, we walked through this one as well. So this was that constraint file. This one happens to have the GPT open source 20 billion model, but we could see that. So if we ever had to change this, we found that, changing the way we constrain the model works, we would do this here. And then I created that model called concise based on that input file. No. So T Chambers 807 says, have you looked at any of the open source Deep CW played with a little bit on receive? No, I have not. Again, I have no experience with AI. Everything you guys are seeing in terms of local AI, this is all based on an 18-hour day from yesterday. I didn't even have the machine that I'm showing you right now up and running. It was like literally in a box, and had to do the OS install, figure out that I should use Olama, and just kind of been working through it. So I don't have the time to keep going through this, but I want to share the process and kind of leave you guys where I left off if you want to take on the research here. All right. So the next big thing is I knew I wanted to do the RAG. So I installed this thing. I realized that there's this thing called Open Web UI, and Open UI is the piece that allows us to create a separate knowledge base and have that be augmented with the model or the output using our knowledge base plus it. I also found out that for whatever reason on Ubuntu 2204, if I don't run it with a dash no sandbox, it sits in this weird loop with trying to do what looks like a container issue with Chromium. I didn't bother to look into it. So I disabled that sandbox feature. So far, we have been talking about what I'm calling the direct model approach. So what we are doing directly in Olama with the run command, that is the direct model testing. So what I pivoted over to was, again, the retrieval, augmentation, and knowledge base section. And again, here, just to kind of paraphrase my actual notes, I kind of talked about it. So my goal is to build a domain expert system. For this, we need to augment the core models with external data using a technique known as RAG or RAG, retrieval augmentation, blah, blah, blah. And I've talked about this already, where my goal was to start with what I personally consider the sources of truth. For me, I happen to look at people that I trust and respect and have authority in the areas that I want to build this system. I also included for other people to follow along why I picked these 4 knowledge base articles to start. We've talked about Project Nomad for a while. I haven't looked at it. I know it's available. I don't know if they're doing anything with AI. Okay, but thank you. Few people have asked already. Unfortunately, like I said, guys, I don't have time to go down this rabbit hole, and although this is an area that would really interest me. Um, so this next step here talks about what we're going to be finally creating called the knowledge base. And I had to figure this out. These are the actual steps of going to something called a workspace, clicking on knowledge, clicking create. I'll show you this in a second. So we're going to do this right now. Then we'll start a new chat. And then I go into how I assess and grade all this. These were all of what I'll call my dimensions of grading it from is it correct? If it was correct, was it complete? What was the retrieval quality like? That has to do with if it went off to consult a source, did it actually accurately pull in uh, information correctly? All right. So this is the that approach document. So what we want to do now is we want to go ahead and start it. I'm going to go ahead and quit this here real quick. So let me go ahead first and make this larger for you guys. So now we're using, we have Olama installed. We have our list of models. And now we want to, oh, what did I do? Sorry, guys, I can't use my hotkeys as I've mentioned multiple times here. To do Control Shift Plus, it'll cause issues on the remote display. All right, so I want to show you what the command looks like for run. And again, all it's doing here is running Open Web UI, no sandbox. So this might look a little bit to people like ChatGPT, right? What that interface looks like. Okay, so this is from, I like the handle already. From the Prepared Homes or Prepared Home Solutions. This is sounding a lot like what I'm trying to do with my developing my own offline repository. Yeah. So if you have the repository first, I showed my repository earlier in the stream, right? So my full repository, did I close it? I did close it. Again, for those of you guys who may have joined late, my full repository looks like, where's resources? Resources, and I've got it on everything, but like my radio resources, for example, look like this, where I've got a super hierarchical build out. In fact, I'm wondering if I've got NVIS in here. Yeah, these are some of the older NVIS articles. So I need to definitely add some of these pieces at some point. Okay. Okay, so this says, wow, I haven't opened Web UI in a while, but it was a great tool when I was exploring. Yeah, and we're going to see where the limitations are now for local AI. So I'll open this up here. And it looks like if you guys have ever gone to like Chat GPT, for example, a lot like it. And let's start with so the first thing I wanted to do was go over to, we're going to open the sidebar. And again, the goal here is to augment whatever model with their own knowledge base data. So if you go to workspaces or workspace, you'll notice that there's this thing called knowledge. And I created one called military NVIS. So anytime I want to make sure that my prompt that I'm giving them for any model will use this as sources, I could feed it this. And the way you create it is you go to create, you give it a name, you give it a description, and then you have the ability to add files here. So the one that I created, again, very simply starting from first principles, is called military NVIS. That's the name. And the description I gave that was in a hurry was inventory supplemental NVIS documentation. And then I gave it those 4 PDFs. Again, I could give it more, but this is just to fast fail this proof of concept or proof of technology exercise. Okay, so that's all we have to do is we go to workspace, knowledge, you create it, you add your files. Now we go to new chat, and you'll notice that we've already downloaded stuff with the Olama. It already has all of the models I've downloaded and all of the models that have what I call my concise ones. So we're going to start with the real small one here. We'll do the Olama 3.21 billion. And the way we attach it, which I think is weird, is you hit the pound symbol. And when you do that, you're going to get a context window that pops up. and you'll get this thing called collections or the individual lists. So I wanted to have it say, okay, for this chat session, I want to attach the military invis knowledge. So now at this point, we can also go back and we want to take our question. And it's still going to be wrong here, guys, but I do want to share it with you. Let me get my question. And again, we're not going to cheat. We're going to give it the same one we started with when we were just doing the same plain Jane questions here. And this is a little bit more friendly. But it was nice not jumping into this first. It was nice starting out from first principles. And that's the other thing, guys, I like to tell you. I can't learn anything unless I start with first principles. I don't know what's wrong with me. I don't know if, one thing that used to drive me crazy is I had people I went to school with or have worked with, and they can start fine learning the abstraction where I can't. I need to understand all of the things. And it sucks because the universities now are teaching people with like 5 or 10 layers of abstraction. And it's unfortunate. So I kind of had to start which OS, how to get the graphics card working, and start very slowly, incrementally to the point now where I'm with Open Web UI. In fact, I would recommend, based on my experience, that people don't start with Open Web UI, that they start directly with Olama and directly just kind of using the models on their own. Okay, so we're going to go ahead now and submit this. And I don't know how long this is going to take, but you can see there it just retrieved 3 sources. Token generation was very fast because it was a small model. We can see that it pulled in a number of resources here, including an Arizona state map. That's interesting, as well as an HF band frequency. So queried that. And let's see what it says here. You provided information on frequency modulation FM. No, I did not. And its relationship with wavelength. However, I cannot directly answer your question about the recommended band and antenna for daytime coverage in Arizona. To provide a more accurate response, I would need to know the following, the specific range, blah, blah, blah. So it needs more information from me. And it looks like it tried to spit out an answer, and it's also wrong. It's got kilohertz here instead of megahertz. So for daytime HF coverage, you may want to consider using frequencies in the 7 kilohertz to 14 kilohertz. No, it should be within 2 megahertz and 10 megahertz range. So it's wrong. So point here, guys, is that, and we're going kind of long. We got 76 people here. I'm at a stopping point. Remind me to also go over my grading criteria. So the way that I would take on my next steps are, again, I still haven't jumped to that purchasing decision. I'm testing, for example, the DeepSeek R1 model, that very large, takes almost 20 minutes for it to come back with a response for me. And actually, let me show you that response. Let me see if I have it. I took a screenshot earlier. You guys mind waiting for me to... this is a brand new build. So this would have been under Home, Pictures, Screenshots. Okay, yeah. So here's a, oh, you guys are not seeing this. And I wish I could make this bigger. This was a run that I did earlier. And you can see I'm using the same prompt. It's using the military NVIS collection and what it says, and I'm using the model. So let's go back to Accelerator. So 1, we're using our 4 PDF documents, our knowledge store. We are using DeepSeek R1 concise. So it's constrained by use a bluff, use the bullet points, 200 words. And then we're also now giving it our prompt for daytime HF, blah, blah, blah. We've gone over this. So you can see it retrieved 2 sources. It sat there thinking for 12 minutes. So if this model had value, that would probably be an unacceptable time. And then I'd figure out how to get the right hardware for it. And it gives us this: for daytime HF communication to cover Arizona, use 5 to 15 megahertz. That's the best we've seen so far. Like I said, it should be 2 to 10 with the horizontal dipole or loop antenna. So that's also the first time we've seen the proper use of a horizontal dipole antenna that is correct. And then finally, configured for near vertical incident skywave to ensure regional coverage. That is what the essence of what I wanted the model to get to, was to get me to a point where it recognized that for that one, Arizona should be regional and that we need to use NVIS communication. That did not happen until we started to bring in the knowledge base. The next thing we need to do is fix the accuracy of these bits. So if I was to continue this exercise, this is the path that I would continue to go down. So hopefully that kind of puts things into context. So one, I don't have a recommendation. If I was pressed by my former boss to say, what would you get today? I would say, DeepSeek R1 with 70 billion parameters at what size is it? What size is it? This is important. We're going to do Olama list, grep, and pro search for DeepSeek. We can see that we need 42 gigs of space, which means at a minimum, we're probably looking, if we didn't care about the future, just to get this thing to run quickly so it doesn't take 12 minutes, probably 48 gigs of virtual memory on a GPU, if that's the route we want to take, right? So what that would mean for cost, for example, let's say that this model works, the knowledge base works, we don't care about the future, we're fine working with this model forever. 48 gigs, what that would mean is we could potentially look at a few options. I don't know if you guys want me to share what I'm thinking, but there is a graphics processor that came out several years ago, and it's the NVIDIA RTX. I want to say it's the 3090. And the 3090 has 24 gigs of VRAM, and there are options to run these older hardware in a dual configuration on a single machine. And I found a gaming site that has it, with storage, CPU, case, cooling, and a power supply that can accommodate this thing. And it came up to about a little over $4,000. And what's funny is it's not just the video card, right? Those two video cards are about $800 to $1,000 a piece in today's market. It's also the motherboard, but more than anything, it's also the power supply unit. To power those cards, you need like at least 1,000-watt power supply. So there's more to that. The second thing we looked at too, which would be interesting, is if you wanted less power consumption, which you certainly would want in a grid down scenario, because I could not imagine running and I'm just going to kind of go off the cuff here, guys, and then I'll answer some questions. So personally, I would not go with that gaming platform. Again, assuming that we want to use DeepSeek R1 and we want to fit in GPU so that we can get some reasonable speeds of responses and we're able to tune it with RAG. I wouldn't personally go with that dual RTX 3090 because of the power demands of the processing unit. And for someone, for myself, who is mostly off grid and only has power here and who does a lot of work running stuff off solar and battery, it's a bad fit for my personal off grid case. Now, the Mac M4s with the unified memory architecture, while it doesn't win in some areas, the fact that it uses what they call a unified memory architecture means that there is no difference between the shared memory of the CPU and the GPU, and allegedly is very fast. And looking at like a 96 gig model, I think puts us in that same $4,000 to $5,000 range, but has the lower power consumption. So for me, if this worked, that would be an option. And then I also ran this idea by someone else saying, hey, you might want to go bigger models. So some of the bigger models that are like 96 billion points or 120 billion, that system would no longer be the right platform. So this is where I said if I wanted to go crazy, which I'm not going to, because I still don't have a model that meets my real world application yet. I had a friend, kudos to this gentleman, who told me, look at DGX, Delta Golf X Ray Spark. Okay. And it's 128 gig of unified memory. It is a specific, it's not a toy as he likes to call it. So one DGX Spark with 128 gigs of um, shared memory runs about $4,700. But you can link two of these together to get you to a total of 256 gigs. So this will give you a future proofing for probably a couple years. But again, you're going to be at $10,000 if this stuff all works. So again, in summary, I'm probably the last person that should be talking about AI, but I did want to share with you my overall process for all of this. So hopefully it was helpful. The stream is an hour and 35 minutes. So let's see here. A couple questions, answers. So Teflon says RTX A6000. Again, we need a lot more context on that one. We got another recommendation for an AMD AI Pro RX 9700 would be the buy. This is from Preston. Hey, Preston. I know Preston actually. Teflon 000 says correct, future proof it with an NVLink capable cards to run a Mac. Yeah, so what he's talking about here, NVLink has its pros and cons based on my very limited research of only doing this for a day. Uh, NVLink allows you to connect multiple systems together so that you can take, for example, a system that initially has, let's say, 128 gigs of unified memory and connect it to a second physical unit to double it. Where the research suggests the problem is, it's going to be on the path between those two. But NVLink is kind of like the de facto standards of how you link multiple systems together. We got one here. Mac can use MLX to greatly improve local model performance. Good to know. NVBL42. Oh, question. Would it be able to have an agent run HF propagation prediction software? I don't know. So for me, again, the whole point, I don't have the answer. And the whole reason why I did this video is not to tell you guys what to do, but I wanted to share with you my personal process on how I like to solve problems, because I can't finish solving this problem. So if I was going to take your question, the same with the way my former boss kind of asked me, which hardware would you buy? And I went down the process. You'd have to do some research. So, for HF propagation in general, I have personally found that you really don't need AI for that, in my humble opinion. I wrote something called ET VoaCap, which is built into MCOM Tools R6. And like I said, shoot, about a year ago, I had read from Rockwell Collins the full analysis on how to use VoaCap engine. So I personally would prefer using VoaCap offline with current sunspot smoothing numbers, and it runs on my little dinky field notebooks, and I use that all day in the field, and it generally gets me in the neighborhood. So I don't know how much value you would get. In fact, short of like storm or solar activity that impacts HF throughout the day, like blackouts, for example, the work that has been done with VoaCap over the last 7 decades. In fact, the research for VoaCap even predates VoaCap itself, was done pre-computer. The U.S. military was actually capturing metrics on where in the world two circuits were, where one radio station was, and the other, how much power, what the soil composition was, how much power, the whole shebang. And VoaCap is a surprisingly good model that runs on, I mean, I can run it in seconds on my hardware. And in fact, I can predict and brute force for the entire US. I can tell my software without an internet connection and without AI, using VoaCap and just using the sunspot numbers. I can say, I only have a 40-meter antenna right now, and I want to do WinLink on Vara. And I can have it literally do a calculation of every single Vara station in the US between my path and theirs. and it takes less than 30 seconds. In some cases, like 15 seconds. And for me, I feed it the power, the mode, again, the circuit path with the offline map, and it's accurate 90% of the time. So I feel like that's a problem I would never want to solve in this space. I just don't see the value in HF prediction, but that's just my thought. Good question. Um, let's see here. Is it okay if I put a link to a video that can hopefully help inspire you further? It is by another creator with around the same mentality. Oh yeah, please, absolutely. Go ahead and drop a link in here. Again, I'm not going to be able to move this further. Like I said, I have MCOM Tools R7, my next big project. I've got a shortwave interview I'm doing tomorrow. I've got the one I got to record or edit, which has my buddy Jason KM4ECK. So at the end of the month, Jason is going to be on the shortwave broadcast. And I've got 3 books in pipe right now, and I've got member content, all kinds of stuff. So this was just a 1 day, I guess, day and a half kind of detour. But post that. So Tango Oscar Mike says, glad you brought up the power issue. Yeah. Again, if you no longer, so the big issue, in addition to you having a tie to the internet and having a monthly bill based on tokens with these providers, if you spend $5,000 or $10,000 on a machine, you have to weigh that too, of how much would it cost if you were able to do the same thing online, but then also what it's going to cost you in terms of your actual power bill. And if you don't have a power bill and you're using battery and solar, 1,000 watts is a lot to run for crunching some simple questions. So my pleasure. Since PlayStation was used for science research in the past, yep. I now have to go see if a PS3 will run local AI. That's interesting. So I worked for a biotech company in 2008 until 2012 in the Carlsbad area. And I was responsible for building genomic search engines where we had these products called assays, and they were a way of doing genetic research. So, for example, my search engine would allow researchers to search for like the gene, like BRCA1, BRCA1, that's linked to breast cancer, and show you all the products. And at that time, one of the comp sci PhDs I worked with, Chris, he was actually trying to pitch for PlayStation 3 cluster to help crunch a lot of the genomic research. So that was a lifetime ago. Like I said, for me, I think, gosh, that's 15 years, more than, yeah, almost 15 years back. So that would be interesting what you find. Let's see, we got prepared ham or home solutions. The ideal version of mine was running like 20K for hardware. Yeah, that's big, and that's going to future-proof you for a while. I honestly believe if I were to make this investment right now, because I have a feeling I could fix this model, the current state, I think I would be going with an M4 Mac with unified memory, the Pro model. If they have it for 196 megs, I would get it. But if I was on a budget, probably 128 gigs of unified memory is where I would go. But yeah, I'm not surprised by your 20K hardware amount there. Prepared home solution, but I was looking for a complete modular hardware setup. I think the M4 might be a good thing to research. Again, I can't tell you. We got an off-topic question here. Since you got a hack RF, should try Mayhem. Oh yeah, I run Mayhem as a standard practice. Been doing that for a while. Steve says, oh, Steve's a very good member, very long time. Thank you, buddy. Good to see you here. With vocap, are you implementing Spark to get better propagation? No, I'm not. Like I said, for the propagation tools I built using just kind of my wrapper on the front end, it works 90% of the time for short, mid, and long range communication. Never have an issue with it, very rarely. And when I do have an issue, it's either because it's not the right time of day, which the prediction is telling me, or there's some type of other external factor like a solar storm is going on, for example. So yeah, I have no interest in using AI for HF propagation. I think it's a problem that doesn't need to be solved that way, unless Yeah, I really don't. And then there's ALE to brute force it. So, and just general rules of thumbs. Bob Hill says vocab was mature in the early 80s. Yeah, it still is. I know there are other models out there, but like I said, for me, again, you have to be, not to get preachy, I'm a pragmatist. The fact that I could take a old Panasonic hardware that is on a 7-inch notebook, never connected to the internet, have a vocab model, have GPS on there, have my offline index. I already know where I'm located, where the other station is located. I could already have vocab do the math on that circuit. I know which mode I want to use, whether it's uh, JS8, for example, and I know what the signal or what the SNR quality requirements need to be for that circuit. It does such a good job. I don't. It's kind of like the Pareto principle. If you guys are familiar with that, it's a classic violation of the Pareto principle, where getting VoaCap up and running took 20% of the effort, and I get 80% of the value out of the prediction. Right? You can also flip that around, saying, okay, to go to AI, I'm getting 80%, or let me see, to do the other 20%, to get to 100%, we can use AI, but it might be 80% more effort. And I just don't see like that dollar amount of hardware investment and pulling in data. I mean, we can pull historical SWIPSI data, the Space Weather Prediction Center, and feed that into models. It just seems like a lot of work. So unless you're going after a government contract and targeting, for example, like the U.S. Navy, which is interested in this topic, um, I don't see it for the average person. In fact, if I was going to do a commercial product and couldn't make what I do here on YouTube work for me, I would probably go down the path of chasing a government contract and building a product based on this stuff, but more from like the offline capacity. Um, Let me ask somebody else here who hasn't talked. This is from Galgan Zul. My 9-year-old mind range gaming rig can run Quinn 3.6, 3.5 billion at A3B model choice. Oh, yes. So the model choice does factor in a lot. And that's why I started out my research by testing all the models, as many as I could, with the same question on the same hardware, even if I had to wait 20 or 30 minutes, because I wanted to evaluate whether a model was appropriate. And again, for me, the trigger is if it solves a real world problem and it is more than anything accurate, I don't care about token count, then that would be the tipping point for me to make a decision on whether a financial and hardware investment were worth it. I did not get there, but I know what the path would be to get there. And again, my path is trying a few more of the larger models and really doubling down on the RAG approach of using the retrieval, augmentation, and generation technique with very well curated knowledge sources that you feed to augment the generation. Let's see what Clayton says here. You might have answered this already, but do you have a Heltec V4 on your Amazon store? Where do you buy it? No, I'm not happy with the current one. The members don't even have this. Actually, there's only 3 people that are going to get the new Heltec V4 case. I've got 100 of these. I like the overall design that I had the partner modify it for me. My goal was no battery, SMA connector on the top. I'm going to Velcro this to the back. The problem is that there's some flex here, and I feel guilty selling it. If I do, I'll probably sell these and just blow them out at not a loss, but less than what I'm planning to. But no, members will be first crack to get these. It'll be next month. It'll be on the shop, but it's going to be close to Buy Me a Coffee members. And that's just because I need to give perks back. That's part of the biggest support I get is from Buy Me a Coffee. Without them, I would be out of business. So while I do put out most of my content out online, for example, they'll get the approach document, they get early access to the store. In a lot of cases, I will give them early access to videos when I'm able to do it without ads. So yeah, that's a perk. I have them. They're not ready. So there were 2 people that won an ad hoc contest today. They'll get one. And then my buddy S2 Underground and Amron, JGS, are going to get one as thank yous for being on the Shortwave show. But right now, they're not publicly available. I don't even know if I'm going to even do more than this run just because it was a lot of effort and the it sucks. I'm not a businessman. The margins on these are so low, and I'm not terribly happy with 3D printed stuff in general. Uh, I may sell what I have. I haven't quite decided, but yeah, there'll be a few going out. All right. Oh, Bob Hill, my buddy, Rockwell had vocap run on their old ass AM or AIM 65 computers somehow. Yeah, it's crazy. And all that stuff was written Fortran. In fact, if you guys have ever seen a vocap input card, there's a reason why they call it a card. Anybody else here remember why they call it a card? But uh, vocap was initially written in Fortran, and the input was actually on punch cards. So you had to be very methodical, very deliberate, and you actually had to feed your input on a physical paper punch card into a machine. And to this day, so the big problem I had is that my card format. So part of the work I did in MCOM tools R5 or R6 was trying to figure out. I'm going to use some horrible language here. It was a mind f for me to grok how to generate the vocap format for input because it's from an era that has long passed. And in fact, that's a good point. Where AI will 100% fail is in these areas that we're talking about domain expertise. So to kind of bring this back, when I talk about vertical domain off-grid systems, I'm talking one where let's say that I want to ask it a question fully offline about esoteric topics, topics that are not well known. They're tucked away in these micro niches. And not only are they tucked away in micro niches, they are from 20, 30, and 40 years ago. So some of the areas where AI will fail is ask it about vocap, ask it about a BPQ question, right? So unless you know where those sources of truth are, I'm telling you, you will 99% of the time get the absolute wrong answer, and it will tell you. So if I took this project on, you better believe, for example, the way that I would use it, I would build a knowledge base on reticulum, which is an area that I'm deeply focused into right now. I would build one on BPQ. I would build one on modem technology and modulation schemes. I would build one on HF. And in fact, the other real reason, guys, went down this rabbit hole because I have priorities that I have to nail. For example, Bob Hill, who's on, has finally sent me what is now, I think, our 5th or 6th generation chassis. And while everybody in the community is wanting one of these cool chassis for the True SDX, this one is in Coyote Brown, right? And it's got the chassis for or the slot for the 3 amp hour talent cell. It's got design elements to prevent the power switch from turning on. You can plug in your power. It's got a channel for running the cabling. It's got a whole new 3D printed case, which is much better. It has much better hardware. While I should have been today taking photos of this, testing this out, figuring out pricing, figuring out how to do what the shopping cart community calls variations, because we have this in Coyote Brown and Flat Dark Earth. I can't right now. I wanted to go down that path, but instead I needed to prepare for an interview tomorrow. And I'm interviewing someone in the reticulum space called Leo Gaggle. And he identified, like me, that reticulum is the path forward. And he has an amazing knowledge base. He has a site called gaggle.com, GAGGL.com. And I want to make a knowledge base of his stuff for my personal research to support that interview, because I don't have the time, because he's been writing since 2007. He has 20 years of write-ups that I find as extremely high value. So part of the reason why I did not work on listing this morning, even though these just arrived and I know people want them, is that I want to see, and I'll probably do this today before I call this quits. I mirrored Leo's site. So I made a full copy of his site for offline use. I'm going to feed it as a new knowledge base called Gaggle, Gagl. And I'm going to ask the AI to help me, saying, hey, this is what I want to talk about. I want to talk about reticulum. Just give me the sources of where to look. So, and I'm going to be able to do this all offline. Really cool stuff. So yeah, I have to prioritize where my time goes. My apologies if you guys want products right away, but I can't just receive a shipment, a day ago and then sell them right away. There is a time for me to make those ready. And so I'm time slicing my day between, 18 hours yesterday of going down this rabbit hole to share it with you guys, the approach. Mondays and Tuesdays are typically my research and development days where I spend a lot of time working on MCOM tools. Wednesday is my recording day where I go out and test the stuff I'm working on. Again, I don't do content just because I want to pump the YouTube algorithm. In fact, I'm considering very heavily leaving YouTube altogether and going like kind of member only, because I want to spend more of my time doing less video content because I'm a slave to that once a week. I want to spend my time doing more meaningful, deep research that is very opinionated and supports off-grid resilience, off-grid communication, off-grid knowledge silos. And it's becoming very difficult to do that with the way that YouTube is making creators do things that compromises their integrity. So anyways, long story short, the reason why I decided to also go down this rabbit hole yesterday and today was to support research I want to do for Leo Gaggle, given the fact that he just said yes. I only have 2 days and I don't have time to go and read 2 decades of his work, but I do know where I want to focus that effort. Let's see here. I'm going to scroll all the way down here to the bottom. Bob Hill said squirrel. No, Bob, it's important. I love what you built. This thing is so cool. The 5th iteration is nice, but it's coming. Someone was asking about products, but like I said, it's all related. The offline radio show or over-the-air radio show is tomorrow. I needed a research tool. The research tool that might be fun is throwing local AI at this problem, at least to point me where the resources are so I can actually read the resources myself. I'm not going to trust it for anything. Steve says, can we put together a reference manual database in a different topic folder using Google Drive as a repository for everyone to determine what's important to download for their own? At this point, probably not. I'm also, for Buy Me a Coffee, we are using Google Drive today. I will be cutting the cord in 27 with Google Drive. I'm likely going to go self-hosted. I don't want any more third parties to have that stuff. But yeah, I've got a background in enterprise search and data harvesting, and I know how to build these things, but they just take a lot of time. And people are abusing the Google Drive. I think one thing that really bothered me was that we've had people join Buy Me a Coffee. They'll join at $5 a month, which I respect budgets, and then they'll go ahead and suck down everything and leave. It's a real shitty thing to do, but I've seen lots of people do it over the years. So I'm going to come up with a different technique that's going to require that there is some level of people not coming in and just taking everything. Nextcloud. Yeah, Nextcloud might be an option to look at. People are also using some of the services from Proton, but and another one from Nextcloud. Very cool stuff. Steve says, hey, I'm working on some documentation on headless software that could be useful for you. Yeah, unfortunately, Steve, I'm all tapped out. Like I said, I am fully burnt out. Like I said, yesterday was an 18-hour day for me on my day off, and I'm close to crashing and burning. I've taken on way too much. And in fact, my wife told me, don't look at the AI thing. We had breakfast yesterday briefly, and I asked her, I'm like, hey, I know it's Sunday. Is there any way I can just look at this? And I did it relaxed and kind of went into it and put on my headphones and listened to the music. I just don't have any more bandwidth, guys. Like I said, if YouTube doesn't kill me, I think I might end up being the one that causes me to burn out. So I need a little bit of time. I feel like there's way too much pressure on putting out a video every week to stay relevant. I feel like we don't have a whole lot of time in terms of taking ownership over having these knowledge bases and the software that needs to go out there. So yeah, it's just every day there's just a lot going on. So I need to finish out the year and just not accept anymore. So I don't think I'm going to be developing any new products for the rest of the year. I think I'm going to uh, just kind of write it out, get the books written, get the software done, get the box set finished for R7, continue to do the reticulum bits. There is one thing that's super interesting that I've been dying to get to. There's been two video topics I've been wanting to do, and I'm struggling to figure out how to do the time. Um, One is I've been for over a year. I've wanted to do the 100-mile get home unsupported, and that's the scenario where the RV fails, have to ditch it, 20 miles in. We'll jump to the e-bike, have to figure out what to take with me. E-bike runs out of fuel, then have to transition to running on foot. And the goal is to cover 100 miles as quickly as I can, as discreetly as I can, as realistically as I can while dropping gear. And then the other one is I would definitely want to revisit the SIGINT series. I've had the Kraken SDR now for over a year and a half, and I need to get back to doing some direction finding using Kraken SDR and hopefully dispel some real world myths about what DF means. And then I've also wanted to do some EMP stuff because there's a lot of misinformation on EMP. So like I said, I'm all tapped out. I would love to do all the things. I've got a process for doing all the things. Respect everybody that is out here to help me. But you have no idea how research takes time. This is why one of my biggest pet peeves is when I cover some stuff on YouTube and go through a lot of research and development and a lot of R&D. And if it becomes popular, there are other people on YouTube that will just ride that algorithm wave. And they'll even go so far as to rewrite all of the affiliate links for stuff that I've tried and and I just can't stand it. Like I hate that crap. If I was in the Catholic school, it would have been a, fist fight in the yard, right? Kind of thing, which unfortunately you can't do anymore these days. We are way off topic, guys. This was supposed to be about AI, but hopefully that makes sense. So if you joined late, to be very clear, I'm anti-AI. I am anti-AI and pro-human. I don't want to be in a world where AI is a technology that displaces humans in the workforce, knowledge workers that have a lot of value. Certainly not on board with AI companies of buying in mass rare books. Anthropic, you suck. And your data centers should be burnt down, in my opinion, because you are destroying works of history to feed an algorithm by chopping off the spines and feeding that into your system. But I believe that and I don't believe in AI in terms of the data centers that are being built and causing people to lose their homes from eminent domain. I think that's bullshit too. I think all of those politicians should at some point be accountable for that kind of stuff. But I'm a realist. There could be, in my application, use for AI, and it's for a world where I'll be very clear. You run it locally. The power demands allow you to run it off grid. The models are precise and accurate where you can use it for off grid information. And personally, for me, I want to use it as a research tool that I feed and care for to distill lots of information, but I'm still the human that determines whether it's right or wrong. So this is the last thing I think I'm ever going to say on AI, but I did want to spend at least one video, one time talking about where I stand. So local AI has a lot of power, I think, for off-grid communication. So KC3WHJ says, list your wife, take some time for yourself. Yeah, I will at some point. Senor, good topic, Gaston. Thanks for getting some downtime. Oh, and get some downtime. Master of None, DIY. I know this person too. Are you planning on any trips east next year? Yes, I am. I'm planning on going to Tennessee to do a field training exercise on about an 80-acre property. And I'm going to offer that first to the Buy Me a Coffee members. So it's going to be a place where we'll do car camping on this site that still is being cleaned up and worked on. It's been in flight for almost a year. And yeah, I'm going to figure out how to get as many people to come to that. And there'll be 2 or 3 days of off-grid field training exercises, a lot of camaraderie. Um, so yeah, that's in the works. The logistics are what's killer to be able to take that amount of time, and that's the other reason why I'm thinking I may have to step away from YouTube. There's no way to do that. There's at least 2 days of travel on the front end, 2 days on the back end, about 3 days of training, logistics, food, material, all of that stuff. So that's 5 days of doing nothing, and then for it to really count, you kind of have to do 2 or 3 of those back to back. So that's a 2 week commitment. So I'm figuring that out. But yeah, at the very least, if I could only do one just to see what it looks like, sometime before it gets nasty in the Southeast, definitely plan on doing at least two, but possibly three back-to-back 3-day sessions. So I'll talk to that first to the people on Buy Me a Coffee when we get closer. We'll talk about that in the beginning of 2027. But yeah, we've been working on the logistics, the planning. I've done one dry run already out there in Tennessee. The property, like I said, is the big thing that's being worked on. Those storms that you guys had really destroyed structures and other things that were already there that had to be rebuilt. Yeah, it's going to be camaraderie, and yeah, and we're going to do like MCOM tools, install fest at the beginning, a lot of cool stuff. That's the stuff that's exciting to me, if you're into it. And let's see. Follow-up question. Nice. Looking forward to seeing what's being announced. Logistics. That's my life. Let me know if there's anything I can do to help. Yeah, I'll let the community know. Over the last 3.5 years, I got to tell you, I love everybody, but one of my favorite groups on the member Discord is the Southeast group. I don't know what it is about that portion of the country. You guys just have all your stuff in order. You guys have the right mindset. You guys know what the right priorities are. You guys have the right sense of community. And again, I'm not knocking everybody else that we have like across North America and overseas, but for whatever reason, that group, they train together. They help each other out. They're the most active. But yeah, there's some unique, they must put something in the water in the Southeast portion of the US, but you guys are absolutely amazing. Okay, last one, then we're going to drop, guys. We're coming up on, we're over 2 hours already. I'm driving around at work, kind of slow call today, and imagine my excitement when I see a live stream on my MDT. Turned out to be a good day for all. Yeah, go back and watch this stuff. I think so. All right, guys. So Steve, again, I know you're like super anxious. I don't have time to look at anything else. I don't have time to look at Project Nomad. I am 100 and if there was 110%, I'd be 150% tapped out. My mission right now, to be very clear, guys, is I want to get the AI stuff off my chest. The only thing I'm looking at right now is MCOM Tools R7, the downloadable version, then the box set, continuing the work I'm doing on shortwave broadcasting, continuing the 3 fictional works that I'm writing in print that will only be available in print, making sure I'm doing the monthly Buy Me a Coffee streams, and just having enough revenue to kind of keep going between Buy Me a Coffee, YouTube, the little bit of Amazon affiliate stuff, some of the DigiRig affiliates. But that is my marching orders. But again, I just wanted to get this off my chest, and I will definitely get that approach document cleaned up just a little bit, and that'll be in the newsletter. So no more room for stuff. And then I guess to my last, so Whiskey Wild says hurricane preparedness. I think that is it. On a similar note, I guess the fuel is bourbon. You guys rock. All right, guys, I'm the Tech Prepper. Be strong, be safe, and be prepared. Thanks for hanging out for 2 hours. I don't know how you guys do it.